Theorem: if the Neumann problem for a bounded region has a solution, then it is either unique or it is differ one another by a constant only. Proof: let phi1 and phi2 be two distinct solutions of the Neumann problem. Then we have del square phi1 equals to 0 in R, del phi1 upon del n equals to f on C, and del square phi2 equals to 0 in R, del phi2 over del n equals to f on C. Let psi equals to phi1 minus phi2, then del square psi equals to del square phi1 minus del square phi2 equals to 0 in R, and del psi over del n equals to del phi1 upon del n minus del phi2 over del n equals to f minus f equals to 0 on C. Now, by the theorem, if phi is a harmonic function in R and del phi over del n equals to 0 on C, then phi is a constant in R bar. We get psi is a constant on R bar, that is phi1 minus phi2 is constant. Therefore, the solution of the Neumann's problem is not unique. Thus, the solution of a certain Neumann problem can differ from one another by a constant only. Thus, we have proved that if the Neumann problem for a bounded region has a solution, then it is unique or it differs from one another by a constant only.